Hi, I'm Jason with Martel Math. Welcome to another episode of Martel Math. Today we're going to talk a little bit about polynomials, and there's a lot of stuff to polynomials, but it's really not that difficult if you take it one step at a time. We're going to go mostly into the vocabulary of polynomials today, the academic language that we use to understand what they are and what they're made up of. As you dig more and more into polynomials, quadratic polynomials, moving forward, that vocabulary is extremely important to help us understand exactly what we're doing. So let's break it down. I'm going to start with the word polynomial. It is a compound word, two words made into one. We have poly, meaning many, and nomials, meaning numbers. Okay, real simple, real easy. Okay, great. So polynomials mean many numbers. Yay, good. We got some information. Polynomials are made up of things called terms. Let's write that down. Terms. And the terms are made up generally of three things. Each term has a coefficient, a variable, and an exponent. So terms are made up of a coefficient, a variable, and an exponent. Okay, so far so good. We got some vocabulary words, and hopefully that's nothing we haven't seen before, but just in case it is, we'll talk about what each of these pieces are. Polynomial has a coefficient, a variable, and a term. So take something like this, 3x squared. Got 1, 2, 3 things in here. I've got a number, a letter, and this little guy up here, which is a power, or also known as an exponent. So boom, we got our exponent right here. This is our exponent. The little number typically is connected to the variable. You'll see polynomials where the exponent is connected to the whole term or different parts of the term. But in this case, our exponent is applying specifically to our variable. Our variable is the x. And finally, the coefficient is the number at the beginning or somewhere in the term. And what confuses a lot of people is really every term has a coefficient. But a lot of times you might see something like this. Do you see a number there? I see an exponent and a variable, but I don't have a coefficient. Remember, algebra is a little bit about abstract thinking, remembering about things that really are there or are not there. And with everything in the world, I can simply say that this y really is 1 times y. Identity properties multiplication tells us that every number out there times 1 is the same as itself. This will become more and more important as we get further into polynomials. Just remember, there's always a coefficient, and at the very least, it's always 1. And I'll write down my coefficient is the number. Or really, you should say the numeral if you want to be super specific. Number, which is the numeral. There is a variable, which is typically a letter. And finally, the exponent, which is the power, right? Now, the exponent also has a second job. The exponent tells us the degree of the polynomial. And the degree really helps us to understand the largest exponent in the polynomial, which really can tell us how many terms there actually are in a polynomial. So take something as simple as 7x to the third plus 2x to the second plus x. You have a third power, a second power, and really that's a first power. Always a 1 everywhere, okay? So this is a polynomial to the third degree. If we didn't have it, now there's a polynomial to the second degree. Why is this important? Well, let's say you get into something like this, 3x squared plus 1. Well, that's a polynomial to the second degree because we've got a 2 for our exponent. But the reason this is important, there's operations you're going to find where you have to kind of make something up. Use your abstract thinking. Even though there's no x term, there's no x in here that has a 1, if I needed to, for some odd reason, I could make this 0x plus 1. So that helps me to remember that there are possibly 3 terms. And again, there's operations where that will become relevant. But right now, we don't have to worry about it. Just I want you to see that and know that. Now, we've got our major vocabulary handled: coefficient, variable, exponent, power, and degree. And there's a couple other things. Standard form. If you remember, if you've seen this before, standard form, let's write that down. I love writing stuff down because if you don't write, you don't remember. I used to tell my students, the more you write, the more you remember. It's very important to write things down. I don't mean just typing it into your iPad or your Chromebook. I mean physically, pencil and paper, writing it down. Standard form. And standard form tells us to use the exponent and write down the polynomials in descending order. You start with the biggest number and you go to the end. Standard form is exemplified with this. Ax squared plus bx plus c. The largest exponent, the next largest exponent, the smallest exponent. That's standard form in descending order. C-E-N-D-I-N-G order. We've got all the most important things except one more example and two more important terms that we need to understand. I'm going to go back to the black marker for this one. You want to remember the distributive property, which tells you to distribute numbers inside of a parentheses. If I have something, let's take this arrow down over to here, as simple as 2 times x plus 1, is the distributive property tells me to take that 2 and multiply it by each term. I'm going to distribute it inside the parentheses. So 2 times x, put a little arrow there. That way it doesn't look like I just drew some weird parentheses. 2 times x gives us 2x. And I can continue to distribute or to share my 2 with the next term inside that parentheses. 2 times 1 plus 2. 2x plus 2. We've distributed our 2 inside of our parentheses, which if you remember order of operations, the previous video that we did, that's part of your order of operations, simplifying your parentheses first. Distributive property, and when you get into larger, when we're multiplying polynomials together, typically you'll see a lot of examples where you're going to have 2 binomials together. Oh, hey, there's a word that we haven't talked about yet, binomial. So let me time out and back up a little bit. We were talking about the number of terms in a polynomial. Well, what a term is. Coefficient, variable, and exponents. Well, polynomials will have 1 term, 2 terms, 3 terms, 4, 5, 6, 7, 8, 9 terms. Polynomials can have as many terms as there are numbers, but we tend to focus mostly on 1, 2, and 3 term polynomials. They do have their own names. A polynomial with 1 term is called a monomial. So put that over here, monomial. 2 terms, binomial. And finally 3 terms, trinomial. Monomial, binomial, trinomial. That just really tells you how many terms are in the polynomial. Lastly, distributive property, we use something called FOIL. And you're going to see this in usually the first or second lesson of any Algebra 1 textbook that's talking about how to work with polynomials. So take something like x plus 3 times x plus 8. So x plus 3, you FOIL it out, right? F-O-I-L. First, outer, inner, last. This is directions. It tells me what order to multiply things in. We're talking about the terms. First terms, outer terms, inner terms, and last terms. You have first terms here. The x's multiply together first. So come over here. X times x is x squared. Outer terms, the outside of the expression. X times 8. X and 8. So we have 8x. And that's a positive 8, which gives me a positive 8x. First, outer, inner. The inside terms, the middle terms, 3 and x. So 3 times x. Help us draw the arrow so we don't lose track. And we can do this guy right here. 3 times x. So that's also a positive 3x. And finally, last. 3 and 8. What's 3 times 8? 24. And again, these are positive numbers. Next step with this is just simply to combine your like terms. When we say like terms, this can be the simplest or most confusing thing depending on your perspective. Like terms. Okay? Like terms are terms that have the same exponent, the same degree. So I look at this polynomial right here. I've got an x squared. Do I have any other x squareds in here? No, I don't. There's nothing else I can mix with that. What about x to the first power? I've got two terms that have x to the first power, 8x and 3x. Those two can be combined. So we add 8 plus 3, that's 11x, right? So let me come back over here. We have our x squared. We have our 11x. And the only thing left is the 24. There's no other numerals without a coefficient or a variable. So this is our answer to this multiplication of binomials. This is a binomial. There's two terms, x and 3. This is a binomial. There's two terms, x and 8. This is how we multiply them together. This is jumping a little bit ahead. But like I said, this is more of a vocabulary lesson, learning words and what they mean. Polynomials, distributive property, standard form, which tells us descending order. Terms, made up of coefficients, variables, and exponents. Monomial, binomial, trinomial. Like terms, that's how you add and subtract polynomials. And finally, degrees. The exponent tells us the power of a variable, and that tells us the degree of the polynomial. So I hope this was helpful. I hope you learned something. I'd love to see you grab some polynomial expressions off of Google and do some practice. And if you have any questions, if you need any help, you can reach me at Martell Math on social media, YouTube, as well as martellmath@gmail.com. Thanks again for watching. Have a great day.